So as we move into the concept of differentials, we need to recognize that up until now, we have interpreted dy dx as a single entity representing the derivative. Now, we will define dx and dy themselves, allowing us to interpret dy dx as an actual ratio. So we have previously defined f prime of x to be our slope, which is our rise over our run. So dy represents the vertical change of our tangent line, and dx represents the horizontal change of only our tangent line. So dy dx only compares to the tangent line, rise and run. The opposite of that is it's important to understand the distinction between the increment delta y and the differentiable dy. Delta y, excuse my cat, sorry, move. Delta y represents the change in y that occurs when we travel along the curve itself. Dy represents the change in y that occurs when we travel along the tangent line. So let's look at the difference. If we so we're always going over dx or delta x, that doesn't change. But sometimes from that point we go over and up to our tangent line, that's a distance there, versus going over and then up all the way to my function. And this distance here is delta y. So although delta y and dy are generally different, for very small changes in x, the differential dy will be a good approximation of delta y. So this is the important part here. The differential dy will be a good approximation of delta y. So this is a lot of ideas here. Let's get into an example together.